Hello everybody, this is the first lesson in our electrodynamic course. Uh, I'm going today to start with dot product and unit vectors because I found these concepts very important. And maybe you ask a question why we start with vectors in an electrodynamic course. I should say that you will find them everywhere in this course, so it's good to uh, become more familiar with them and understand them better and be able to work with them easily. Okay, let's first I need to tell you about the structure of this video. I first write down the basic concepts here and here, and I am going to solve many problems and like examples in here interactively, and then you will see. Okay, so let's assume I have two vectors A and B and they make an angle theta with each other. Then the dot product is defined this way. So this is a definition. So here this is size or magnitude of A and this is magnitude of B, and this is cosine of this theta, the angle between them. So maybe it's a little bit hard to use this abstract equation by its own, but I will let you know how to make use of this equation. Okay, before I go further on this concept, dot product, I will cover unit vectors, and then I use dot product in there, and then we use them together to do some examples. Okay, so you are perhaps familiar with Cartesian or Cartesian coordinate system where we have x and y and z directions, right? So in the direction of x, I can define a vector whose magnitude is 1. So it's a unit vector. This is why we say unit, because its size is 1. And it's defined in x direction. And j hat, it's defined in y direction, and magnitude is again 1. And k hat in the direction of z, and the magnitude is again 1. So here is a very simple thing. Now, so the concept of unit vectors, it's simple. Now I'm going to use this dot product to uncover some of the like properties of these unit vectors. For example, let's say I had dot I hat. I want this, and you will see how useful these are, these properties or identities. Okay, so let's use this equation. I have I hat in place of A and I hat in place of B. So this means this A here, this is magnitude of this I hat, which is 1. So I say 1 times, and B here is magnitude of this other guy, which is 1 again, and this is 1, and cosine, and the angle between a vector and himself or herself is always 0, right? Because it's one single vector. And we know cosine of 0 is 1, then 1 times 1 times 1 equals 1. And this is the same for j hat and k hat, right? So let's write them in here as well. And then we need to memorize this equation. So j hat dot j hat equals k hat dot k hat equals 1. and to emphasize its importance, I'm going to circle this equation and the next one. Let's first write down the next one. Okay, now I'm going to dot product I hat and let's say j hat. So I hat dot j hat. So here I use again this equation. So this time A is I hat and B is j hat. So magnitude of I is 1 and magnitude of j is 1 again. So it's 1 times cosine of 90 degrees. So I didn't tell you maybe, but the angle between these three vectors is always 90 degrees. So this makes 90 degrees with this one, and this guy makes 90 degrees with this one, and this one makes 90 degrees with this other one. So this is 90 degrees. And we know this guy is 0. So therefore I hat dot j hat is 0. And this is the same for the other dot products. So when we dot product unit vectors with another unit vector which is not himself or herself, it's not the same unit vector, then the result is always 0. So let's write this guy in a more friendly way, because we have to write more of them. Okay, I hat equals I hat dot k hat equals j hat dot k hat equals 0. And so now later you will see how important these equations are and how they make our problems more understandable and easier to solve. Okay, now let's say I want to add two vectors. So let's say addition of vectors. Addition. So let's say I am going to add A and B. So, and what is that? So let's make some examples here. So let's say I'm going to add I hat and I hat. So what is that? So it's simply, this is I hat. If let's say my x direction is this way and y direction is this way and z direction is toward your face and it's out of this surface. So therefore I hat, this is I hat. Plus I hat means I should, so when adding vectors you should always start the next vector from the end of the first vector. So you first draw the vector, the first one, and then draw the next one immediately after that. So like this. So this is another I hat. So therefore this equivalent vector, this is 2 I hat and equals that. Okay? Or let's say another example, I hat plus j hat. So I know I hat is in this direction and j hat is in this other direction. So therefore I have I hat and the size is 1 always. So make sure the size is 1. And j hat, and this size is also 1, but it's in y direction, right? So the equivalent vector is from the beginning of the first to the end of the second. And this guy is I hat plus j hat, this guy. Okay, Now let's say I have I hat plus j hat minus 2I hat. And what is this guy? So I write I hat, then I write j hat, then I write minus I hat, because this is minus I hat, the size is again 1, the direction is backward, so it's to the right, this one is to the left, and minus I hat, so it's minus I hat minus I hat, then it's minus 2I hat. Okay, so now the resulting, let's change the color, the resulting vector is this guy. Or you can simply subtract this one from this one and write it as minus I hat plus j hat. So remember, you always add or subtract the same unit vectors, and they are independent of each other. So when, for example, you see something like this, then you add I hats together or subtract them from each other, and then j hats together and k hats together. But so it's easy, right? So it's minus I hat plus j hat. So if now I from the beginning write this guy, so instead of going this way, I should go this way, because this is minus I hat and this is j hat. So the resulting guy is this one, which is the same as this other one. So they are the same. So therefore, doing the addition or subtraction, we always add or subtract the components or coefficients, let's say, yeah, it's better, coefficients of the same unit vectors. So coefficient of I hat here was 1, and this one was minus 2, so 1 minus 2 minus 1 I hat, and this is alone, so it's only j hat. Now let's make another example. Let's say I have 5 I hat plus 2 j hat. Let's say this is A, so this is my vector A. And let's say 3 I hat minus 4 j hat. So you don't really need to draw these things, although you can always do, but it's not easy to draw things. We want to do some mathematics, it makes calculations easier. So you simply now, you need to add the coefficients of I hat together, so 5 plus 3, 8 I hat, and coefficients of j hat, which is minus 2 j hat. So this is the resulting A plus B. Okay. Now let's do some dot product here. So this is my A and this is my B, and I'm going to calculate A dot B. And now you will see how easy this is if I use these equations, and how hard it is if I use this abstract equation. So let's do that calculation here. It's a rainy day here, and it is raining. I like the sound. It makes me feel, I don't know, very pleased. Yep. Okay. Eraser, small eraser. I need to buy a bigger one. Okay, so now I'm going to calculate A dot B. So this is my A. Oops. and this other one is b, and I'm going to use a dot b. So now let's say I'm going to use only this equation, and I'm very abstract guy. So to do this, maybe you should first draw the vectors. So I say this is my I hat, 2 I hat, 3 I hat, 4 I hat, and 5 I hat. So I have 5 I hat and 2 j hats. And then the resulting guy is this is the resulting one. And let's now erase these things because we don't need them. And this is A, and now let's draw B. Okay, so B, 3 I hat, 1, 2, 3, and minus 4 of them. 1, 2, 3, 4. So, and this is B. So now, how I should get the magnitude of these two, and how I should calculate the this angle theta, because in order to use this equation I need these informations, and it's really hard to use this equation, as you already see. So maybe the best thing to do this is to, I don't know, maybe you should pick a ruler and then measure the size of this guy from here to here, and that would be A, and the size of this other guy from here to here, and that would be B, and then use some devices, I don't know, to calculate, to measure this theta, and then replace everything into this equation and then get this guy. Now who really wants to do that? Nobody. Now let's use another way, and that is these set of simple equations. This is why I'm saying you need to realize, you need to memorize these properties. So now let's say I'm going to dot product A and B. So remember, in order to use these, you always need to write A and B using their unit vectors. So you always need to decompose a vector to its unit vectors. And remember, you always can do this. So there is no vector that can't be decomposed. All vectors you can decompose, so no worries. So I say 5 I hat plus 2 j hat dot. So this is the dot. 3 I hat minus 4 j hat. And then what's the result? It's very easy. It's I hat actually. Okay. So what you need is to dot product this guy by this and this, and dot product this guy by this and this. So let's do it. 5 times 3 equals 15. Okay, so you always multiply the coefficients first, then dot product the vectors. So now this is 15 I hat dot I hat, and this guy times this equals minus 20 I hat dot j hat, and now this guy plus 6 because 2 times 3 j hat dot I hat, j hat dot I hat minus 8 j hat dot j hat. And now I need to use these equations. I already know this guy is 1, so it's 15. This guy is 0. This guy is 0. Oops. 0. And this guy is 1. So this is minus 8. And somebody tell me it's 7. Huh? Yes, it's 7. 7 and 8. Okay, so how easy this equation was and how hard this using this guy was. Okay, this is all for today. Please subscribe to my channel, and oh, I forgot something. Please come and visit us at solvephysicsonline.com. Let me write it here. Sorry, solvephysicsonline.com, and this is E. This guy is E. And come visit us at here, and let us know your questions, your comments, and whatever you have in mind, and we would be more than happy to help you with your problems in physics. Thank you, and bye. Bye-bye, bye-bye.